Hello everybody and welcome. This is the Shy Hat and we are HackerFrogs. Alright everybody, so today we're going to be doing two different things. We're going to be solving some hackmyvm.eu machines, and also we're going to be solving some of the hackmyvm.eu CTF Labs. So it's going to be a double header of hackmyvm.eu. So the first thing you want to do is you want to log in to your hackmyvm.eu website, and then you want to navigate to the following page. Okay, we can search for these VMs, and I'm going to search for my first machine of the night. It's going to be called Connection. And it seems that I've been logged out. Okay, so I'm going to log back in again. And then we're going to put in the password. Let me just grab my password from my password manager. And just sign in. All right, so here, we're going to go to the machines link. And then we're going to search for the VM Connection. So the VM connection over here, what we need to do is we need to download it. But before we do that, let's take a look at what this machine is all about. So we see here that this is an easy machine from this user right here named White Crows. And we have to download it before we can access it. So we need to click on the download link. I'm going to put it in a new tab. So we're going to download it from this mega website over here. After you do that, you need to install it on your machine. Fortunately, I've already installed it on my machine, so we don't need to go through that step. But if you're doing this fresh, you're going to need to install this onto your VM hypervisor software. In my case, it is VirtualBox. And then we're going to need to start up the machine. So I've got my Kali machine over here, all ready to go. And I'm also going to boot up the machine itself. So, whoops. So I've got my hypervisor over here. All right, so we need to go down to here. This is the machine named Connection. I'm going to start it. So it's going to take just a few seconds to start up. And after it's booted up, we can start looking for this machine on our network. So we have the login screen here, which means it's running. So we're going to put this away. And then we're going to go to our terminal. So I'm going to set up an environment to solve the machine. So I'm going to, inside of my Kali terminal, I'm going to create a couple of tabs. And then I'm going to resize them so that we can see the text a little better. Okay, that should be big enough. So the first tab we're going to use here is we're going to use netdiscover. So the netdiscover command is going to let us see which machines are on our network. So you run it with the -i flag in order to specify which networking interface you want to use. We're going to use eth0, which is the network that all of my virtual machines are running on. So I'm just going to run that. And I have to run it as root, so I'll add sudo in front of that and supply my password. So this should populate in a minute or two. It takes a little bit because it's scanning all of the IP addresses on the network. So while we're doing that, let's set up some other things. So looking at the machine over here, let's take a look at the notes. It just says nice and easy VM with the winky face. So this might or might not be super easy. It really depends on what your definition of it is. But I don't want to see this. So I think I remember what IP address this this machine has on my box. So I'm going to do a little bit of cheating. So on my second tab, I'm going to run an nmap scan. So nmap is going to be, I think this one was 10.0.2.14, and we're running nmap with against all ports, and we're also going to, this isn't right. We're going to run it as very verbose to get output as soon as possible, and we're going to run it with T4 in order to Neospring, hey, hello, and rip it to you as well. You're going to lurk, that's fine. I'm going to give you a little redeem because I appreciate all the viewers. And let's give you a go-to hack.
Mr. Hat, may I please be excused from class?
Well, Kyle.
Yes.
You hear me? You go to
Hack.
You go to
Hack.
You
Have a great day.
You have a great day, Neospring. And to anybody who is listening right now, do you hear the music? And if you hear the music, is it too loud? Because I certainly don't want the music to be drowning out my my voice, because the music just isn't that important. All right. So everybody, I'm going to run my nmap scan against this address right here. Just let me check to see if so we haven't picked up the machine quite yet. Let's run this scan and see if my guess is correct that the machine is running on this port. Okay, so it seems like that is not the correct IP address. Let me check my... So we've got a .2.3. Let me try .2.3 then. Okay, that's not it either. So 13. Okay, so it might be 13 over here. So let's try that. Okay, so I think this is it. So we ran the scan. It came back really quickly, and it discovered the following open ports: number 22, number 80, number 445, and number 139. So these last two ports over here indicate that some sort of SMB file share is available on the machine. Port 80 indicates that there is HTTP open on the machine, and port 22 indicates that there's SSH on the machine as well. So let's do a second nmap scan that covers those ports. So it's going to be 22 and 80 and 139 and 445. Additionally, we're going to do common scripts against those ports, and we're going to do version enumeration with the following commands on our nmap command. So we're going to run that. Okay, so what do we see? So let's take a look. So we've got port 22 running SSH on this version of OpenSSH. We also have port 80, and it looks like it's running an Apache server. On port 139 and 445, we see Samba SMB, which means that this is a Linux machine that is running Samba. And so the next thing we want to do is we want to check to see if there's any open file shares on the system. So since we know that there is SMB available on the machine, we're going to check to see if they have open file shares in their SMB file share. So we're going to do it with the following nmap script. So that's going to be this one right here. Let me clear this off. That's going to be nmap, and it's going to be port 139 and 445, and it's going to be tac script smb-enum-shares, and then it's going to be this IP address right here. So the script is going to run to see if there are any open file shares on this system. Okay, so we're going to run that, and we get these results. So we can read this file share right here. It is called share. So we're going to try to connect to it. So the scan says over here, anonymous access read. So we can at least read files on this file share. So that means we're going to use SMB client to try to connect to the system. So the command is SMB client // then the IP address, then / and then the name of the share. In this case, it is also share. We're going to tack on the -N at the end in order to log in anonymously. So we log into SMB and we're in. And then we're going to do an dir to see what's in here. So there's a directory in here called HTML. So just in case there's some sort of weird configuration problem on this particular file share, I'm going to try to go to the level above this directory. And nothing's changed, so there's no security problem there. That's good. Well, I mean, that's bad. So I think that ls also works. So we could, okay, so we can run ls, but we can't run it with the LA flags. Okay, so let's go into the HTML directory. And then we see here that there is a, oh, okay, so I did not, okay, so I didn't, I forgot to remove my stuff from this machine, but it's okay. I'll explain what I did inside of this machine. So basically, there was this index.html file over here. So what I need to do is I need to download that. So I've already done a bit of tomfoolery over here and put these files here, but you could ignore these, and I'm going to get the index.html file, and then I'm going to exit. Okay, so let's read that file, index.html. So over here, this seems to be a default Apache server web page right here. So that kind of gives us an indication as to the fact that we might be able to upload. We might be able to upload files successfully on this target. So what we need to do is we need to access the machine. So to access the machine, we're going to do the following, and it's going to be, let's see, we're going to access the website for this particular machine on our web browser. So it's going to be 10.213. Okay, so this is the default Apache 2 Debian page over here. So because we were able to see a web page that looks kind of like this on the SMB file share, then we suspect that we might be able to access the web directory over here. So we can confirm this by giving this an HTTP at the front, and then give this index.html. So we see it works over here. So this might be the file that we downloaded. So what we need to do is we need to test. We need to test, and we can test this by going back to the terminal. And in the terminal, first of all, I'm going to get rid of that file. Then I'm going to go into my temporary directory. And from here, what I'm going to do is I'm going to create a test file. And it's going to be echo, and we have file upload. And I'm going to redirect that to test.txt. So we've got this file over here that we can upload to the server, and if we have upload capability, we should be able to upload this to the website and access it from there. So we're going to go back into SMB, and then we're going to enter that HTML directory, and we're going to put the test.txt file there with this command. So NT access denied, opening remote file, HTML test.txt. Okay, you know what I should do is I should rename that file. So I'm going to exit real quick, and then I'm going to rename the file test.txt to upload test.txt. Okay, then I'm going to try again. And I'm going to put that file there, put upload test.txt. And we managed to do that. So this should be on the website now. So on the website, instead of navigating to index.html, we're going to navigate to upload test.txt. And we see here that we have file upload because we were able to successfully upload that file. So most Apache servers on Debian are able to run PHP files. So we could use a PHP reverse shell. We could use a PHP reverse shell to gain access to the system. So I've got a link over here. Let me grab it. So I'm going to paste this into the chat. This is my typical PHP reverse shell that I like to use on these kind of challenges. And what I'm going to do is I'm going to download that using wget on my system. So here I'm going to exit, and then I'm going to paste in the command to wget that reverse shell to our working directory. And the next thing we need to do is we need to set up our reverse shell. So in order to set up a reverse shell, I'm going to go over to another tab, and then I'm going to get our IP address. So the IP address we can get with the ifconfig command, and we are on the eth0 interface, and this is my IP address on that interface. So your interface might be different and your IP address might be different, but we need to get this information in order to set up our netcat reverse shell. So we're going to do netcat, and then it's going to be NLVP 443. This is my typical port that I like to put my netcat listeners on, and because port 443 is associated with HTTPS, and it is less often blocked by firewalls. So I'm going to run that, and then I'm going to have a netcat listener listening on port 443 for a potential reverse shell. So we can go back, and then we can edit the PHP reverse shell.php file over here. So I'm going to rename this, and I'm going to, because that's a bit long, I'm going to rename it PHP shell.php, and then I'm going to edit it using nano. So nano, and then PHP shell.php. So over here, we need to edit a couple of variables in order to get this working correctly. What we need to do is we need to change the IP variable over here and the port variable to the variables that match our attacking machine. So our attacking machine is going to be 10.0.2.16, and our port that we're listening on is port 443. So we need to make sure that these two variables are correct inside of the PHP shell.php file here. And then we're going to save and exit. Okay, the next thing we need to do is we need to upload this file. So we can go over to the SMB share, SMB client. We're going to go and log into it one more time. And then we're going to go into the HTML file directory, and we're going to upload the file. So we're just going to put php shell.php, and that's going to upload the file. So our file is uploaded over there, and then we can exit. So the next thing we need to do is we need to access the PHP shell file on the website. So we're just going to copy this name, and then we're going to go to our web browser. So on the web browser, we're going to navigate to the phpshell.php endpoint. And after we input that field to demonize, this is quite common and not fatal, no route to host. No route to host. Did I put in my variables incorrectly? Let me check one more time. So over here, oh, it's 15. I made a mistake. Okay. Wellington. Wellington just subscribed on YouTube. Welcome to the crew, Wellington. You are now a Hacker Frog. I will redeem an audio clip for you. It's going to be Frog Song. All right, welcome to the crew, Wellington. So I'm going to need to edit this file one more time, and I'm going to nano into it. And I guess I got distracted. So the IP address for our attacking machine is 15, not 16. So I'm just going to edit that. I'm going to save one more time. And I'm probably going to need to rename this file. So I'm going to rename it phpshell2.php. Okay, so I'm going to rename it, and then I'm going to re-upload the new version. I'm going to use SMB client, go into the HTML directory, and then I'm going to upload it using the put command. Okay, then I'm going to exit, and then I'm going to access the file from the website. And I'm going to use the new name over here. And then I'm going to run this. Okay, so we should have a reverse shell on the target now. Let's see if we do. Okay, so we have a reverse shell on the target. We're in. We're in. Okay, so it says here that that we are this user, www.data, and let's see what directory we're in. So we're in the top level directory here. Let's see if we can improve our shell by using Python. So what we need to do is we need to find out if there's Python on the system. So the Python command is at this file location. So what we need to do is the following. It's going to be python-c. And then we're going to put it inside some single quotes, and it's going to be import pty, and then semicolon to end that. And then we're going to do pty.spawn, and then inside of these parentheses, we're going to put bin bash, and then double quote, and then parentheses, and then single quote. So this is going to upgrade our shell a little bit so that we can see what user we are and what directory we're in. So over here, we have a slightly better shell. And the first thing I like to do when I get onto a system like this is I like to see if I have any sudo commands. So what I'm going to do is I'm going to do sudo l. And we see that sudo is not present on this system right here. So what we can do next, is we can see if there are any what are they called? Super user ID binaries, SUID binaries they're called. And these are binaries that have unusually high permissions, and we might be able to use them for privilege escalation. So in order to find them, we can use the find command with the following permissions. is going to be U equals S for SUID binaries, and it's going to be type file, and any error messages we're going to put into dev null, and let's look for these binaries. Okay, so there's a bunch of typical binaries with the SUID permissions, but we also see one that's unusual. So what that one is this one right here, the GDB, the GNU debugger directory, GNU debugger binary, and this being run with the SUID permissions means that we could potentially abuse it for privilege escalation. What we can do is we can search for it on the following website, which is gtfobins.github.io. And over here, if there are any Linux commands we can use to abuse privileges or escape from limited shells, we can find them all over here. What we need to do is we need to search for the GDB binary in here. So it's going to be GDB, and we have SUID capabilities. So we can click on this SUID button here. So it says if the binary has a SUID bit set, it does not drop the elevated privileges and may be abused to access the file system, escalate or maintain privileged access as a SUID backdoor. If it is used to run shell-p, omit the -p argument on systems like Debian that allow the default sh shell to be run with SUID privileges. The example creates a local SUID copy of the binary and runs it to maintain elevated privileges. To interact with an existing SUID binary, skip the first command and run the program using its original path. Okay, so it looks like we have to run this command right here, and this command is using Python in order to open up our root shell. So we have to note here that this requires that GDB is compiled with Python support. Okay, so let's run this command right here. So I'm going to copy this. And before we run this command, what we want to do is we want to understand a little better what this command is doing. So what we can do is we can feed this into ChatGPT and have it explain to us what the different parts of this command do. So we can go over to ChatGPT and we can ask it to explain what this command does. And then on the next line, we can feed the command and we can ask for an explanation. So let's take a look. So the command you provided involves using the GNU debugger to execute a series of instructions. Here's a detailed breakdown of what each part of the command does. Okay, so this runs the GDB executable, and then NX. This option tells GDB not to execute commands from any initialization files. This ensures that the command execute in a clean environment without any user-defined settings interfering. Okay, so this part of the command is going to execute something using Python, and it's going to import the OS module and then use a method from that module. So the EX specifies a command to execute within GDB, and then it runs this Python command over here. So the Python command executed within GDB imports the OS module, and then the function replaces the current process with the new process, which in this case is a new shell. So we're creating a new shell using the Python capability within GDB. And this is going to run the shell process, and the -p flag is passed over to the shell to preserve the effective user ID, often used to maintain elevated privileges such as root. And then exquit is going to tell GDB to quit after executing the previous command. It ensures that GDB does not stay running after executing the Python command. All right, so let's run this command on the server in order to elevate our privileges. So we're going to go over to, so we're going to paste in the command, but we're going to provide, oops, this is not going to work. Okay, So let's try to type out this command ourselves. So we know that we have to refer to this particular file path right here. So we're going to do /user/bin/ddb, and then we're going to give the nx, and then we're going to execute Python, import os, and then os.execute, and then it's going to be bin sh, and then it's sh, and then it is -p, and then it's going to quit, and we'll run that. All right, so we ran the GNU debugger, but instead of going over to the debugger, it ran our Python command, which opens up the root shell. So we're going to clear this. Whoops, we can't clear this. We're going to ask, who am I? And we are root. So we have rooted the system. And when we root the system, we have to play the root redeem.
What are you?
I'm system root.
Okay, so now that we're root, we can go to the root directory and we can get the flag for this system. So we've got proof.txt. We're going to cat it out. So this is proof.txt. We're going to copy the flag and we're going to submit it. So copy that and then go back to hackmyvm, and then we're going to put it in the flag submission field and press submit. Okay, so we got the correct flag. So there's one more flag available on this as well. So there's a user flag. So we're going to go back and we're going to search for the user flag. So the user flag is going to be, we're going to search for the user flag. I'm just going to do find and then name user.txt. And it seems that it is not there. Let me look in the usual places. So I'm going to go to var www, and I'm going to go to HTML, and it is not here. I'm going to go to the home directory, and there's a connection user, and there's local.txt here. So I'm going to read that. And this is the second flag we need to submit to the system. So I'm going to copy this, and then I'm going to submit it, and we'll be finished. Okay, so the flag, we will paste it in and submit. Okay, correct flag submitted, congrats. And then we go back. And we're now finished with this system because there's no more option to submit flags. Okay, so now that we're finished, we can upvote this particular challenge by clicking on the heart. And now we're done. If anybody wants to check out some write-ups, we have write-ups from a lot of different users in different languages all over the place here. So we've got some in English, some in Chinese, some in Spanish, and that seems to be it. All right, so everybody, I hope you had fun solving that challenge over here on hackmyvm.eu. This one was called Connection. And we're going to be moving on to our second system of the night. And that's going to be a box called Hommie. So this box is called Hommie. So what I'm going to do, because I have modified the box a little bit since I was doing my testing on it. What I'm going to do first is I'm going to shut down this system here and close it. I'm going to send the shutdown signal, okay? And I'm going to do a quick little uninstall of my current version of Hommie, and I'm going to install a fresh version. So I'm going to remove the VM. So here I'm going to demonstrate what it's like to install the system fresh. So I'm going to go to File, and then I'm going to Import Appliance. And then I'm going to use my local file system. I'm going to hide this away so you don't see all of my files. And I keep all of my VMs in a certain place. Okay, then I'm going to hit the import button. And so that's going to take a little while to import the appliance. But after that, then we have our Hommie system. So this is not connected to any particular network initially. So what we need to do is go up to Settings, and we need to go over to the Network tab, and then we need to set it to. So I made a NAT network to put all of my VMs in, and I'm going to make sure that it's on the same network as my Kali Linux attack box. So I'm going to click OK. And then I'm going to start up the machine. So we can see the box starting up over here. All right, so it seems to be running now. So I'm going to put this away, and we're going to go over to our Net Discover over here, and I'm going to Net Discover one more time. So I think this machine is going to appear at a certain IP address for me, but I could be wrong. Yeah, this is what I expected it to be. So this is where the vulnerable system is. So we're going to start our Nmap scans. So let's do that. So I'm going to clear this off, and the other tab I'm going to clear that as well. So over here, what I'm going to do is my Nmap scan, and it's going to be just like this, except it's going to be on this IP address. So we're going to scan that, and then we discover these three open ports. So this is FTP, this is SSH, and this is HTTP. So we can run our second Nmap scan. That includes those three ports, 21 and 22 and 80. And then we're going to run it with the standard scripts and the version information. So over here, we see the results of the scan on FTP. We see that anonymous FTP login is allowed, and that there is an index.html file in here. But the problem is that this is an empty file, so I don't know how much help that's going to be. As well, we see that we have our typical results on port 22 SSH, and on port 80 there is a Nginx. There's an Nginx file over here. So what we need to do is we need to do a little bit more enumeration. So the anonymous FTP file share is the first thing we need to take a look at. And what I'm going to do is I'm going to FTP to that system. It's going to ask us for a name. The name is anonymous because we have anonymous login, and the password will be blank. So a lot of people will FTP, and then they will ls to see what's inside the directory. What we need to do is we need to get in the habit of doing ls with the LA flags in order to see hidden files on the system. And we see that along with the typical directory and upper level directory, we have our web directory over here, which we wouldn't be able to see if we just used ls by itself. And we have the index.html, but it is an empty file, so we shouldn't download that. What we need to do is we need to enter the .web directory. So we're going to go into .web, and then we're going to do the same thing, lsla, and then we see that there is an index.html file over here. So we're going to get that, That's going to download, and then we're going to back out. And we're going to see where we are. So we're in the remote directory /. So what we need to do, what we're going to do is we're going to do a test just to see if we can break out of this directory. And it looks like we can't go any further than this, so that's fine. We're going to exit. And then we're going to cat the index.html file over here. And the index.html file says, Alexia, your ID RSA is exposed. Please move it. I'm fighting regarding reverse shells, and it's signed nobody. So I get the feeling that this is also a web accessible directory, or sorry, this is a web accessible file over here. So what we're going to do is we're going to check on the internet. So on the network, we're going to access the page at that IP address. Oh, this is HTTPS. So you need to make sure that we're accessing it on HTTP. So it says here that Alexia, your ID RSA is exposed. Please move it. I'm fighting regarding reverse shells. Signed nobody. So this is exactly what we saw in the index.html file that we just downloaded. And we can check that this is index.html by specifying it in the address bar. And just for fun, I'm going to check to see if there's anything else in the HTTP source. There isn't. So this is probably another case where we have file upload. So that means that we can try to upload some files. So we have let's download our PHP reverse shell again using wget. So I'm going to download that. And after that's downloaded, we're going to edit the details. So in another tab, we're going to get the details of our attacker machine with the ifconfig file. And on my network, my attacking machine is 10.0.2.15. So we just need to remember that. And we're also going to set up our reverse shell. So we're going to set up our reverse shell. It's going to be netcat NLVP 443. And NLVP means no DNS lookup, listening, verbose output, and specific port number. So this is going to set up our reverse shell listener on port 443. And then we're going to edit the file for the PHP reverse shell using nano, PHP reverse shell, PHP reverse shell. And then we're going to edit some variables in here. So we need to edit the IP variable and the port variable. So the port variable is going to be the port that we specified, which is 443. And the IP variable is the IP address of my attacking machine. In my case, it's going to be this one right here. So we're going to save out this file, Control X to save. Save modified buffer yes, and then save it as this file right here. So we're going to upload this reverse shell using FTP. So it's going to be FTP, and then we're going to log in as anonymous again with no password. And we're going to enter the .web directory. So here we see we've got our index.html. We're also going to put the PHP reverse shell in here. So it's going to be put PHP reverse shell.php, and that's going to upload. So this is PHP reverse shell.php. I'm going to copy this name because this is a bit long for me to type out. And then I'm going to go to my web browser, and I'm going to paste in the new endpoint. The problem is that when we tried to access this page right here, what our web browser did was that it downloaded the file. So what this indicates is that this web server doesn't read PHP files, or rather it doesn't execute PHP files. So this file doesn't run, this web server doesn't run PHP. So we're gonna have to find out, so we don't have a way into the system anymore. So the problem is we don't have code execution on the web server, but there's this note over here that says Alexia. We've got a username and it says your ID RSA is exposed. So we have a file that we could potentially steal. Please move it. I'm fighting regarding reverse shells. So we've come to kind of a dead end in our enumeration. So the only thing we can do when we don't have any other options is we could try scanning with doing a new Nmap scan, but scan UDP instead of TCP protocol. So I'm going to exit from here, and we're going to do a new Nmap scan for scanning for UDP. I'm going to scan top ports. So the problem with let me grab my notes. Hold on a second. Oh, sorry, I was a bit quick to switch over to this machine. I want everybody to know that this is the Hommie machine, and the Hommie machine is located on hackmyvms over here. So I'm going to click into this machine, and I will copy this and provide this to the chat in case anybody else wants to take a look at this VM. All right, so it says here that enumeration is the key tested on VirtualBox, and this is the machine that we're doing right now. So sorry if I neglected to mention that earlier, but yeah. So let's continue on with our enumeration. So because we've run out of things to enumerate, we're going to run a an Nmap scan, scanning UDP ports, and this is how you do it. So we're going to scan top ports 100, and we're going to scan UDP using this particular flag. So top ports needs to be hyphenated, and we're going to do very verbose output, and we're going to do 4 threads on this particular IP address. So the thing here is that when we scan UDP ports using Nmap, we need to scan using sudo. So the entire command is going to be sudoed. So we're going to run this, we're going to provide our password, and then we're going to scan 100 ports using UDP. So even though we're only scanning 100 ports using UDP, this is going to be very slow, because UDP scans are, by their very nature, very slow. That's why we generally try to avoid scanning Nmap using UDP. The other reason why we tend to avoid scanning UDP using Nmap is because there are a lot of false positives when you scan using Nmap for UDP ports. Okay, so we've got our top 100 ports, and this is the problem. So the problem is that we receive a lot of open filtered results, and that generally means that we don't know whether or not these are actually open or not. And most of the time, it's hard to determine which one of these ports are actually open. So the only saving grace here is that we have this port right here called TFTP, and this is also listed as open or filtered. and this is on port 69 over here. So TFTP is a very interesting protocol. So let's learn a little bit more about it from ChatGPT. So over here, what is the TFTP protocol? Okay, so it says here that the Trivial File Transfer Protocol, TFTP, is a simple, lightweight file transfer protocol that is used primarily for transferring small files over a network. It is designed to be easy to implement and uses minimal resources, making it suitable for bootstrapping systems or transferring configuration files and embedded devices. Here are some of the key features and characteristics of TFTP. So simplicity, okay, so it's much simpler than FTP, File Transfer Protocol, and lacks many of the advanced features, and the protocol operates over the User Datagram Protocol, UDP, and it seems to have gotten stuck. So I'm going to regenerate this. So one important thing to note about the TFTP protocol is that there's no authentication or encryption. TFTP does not include any authentication mechanisms, making it less secure for transferring sensitive data. So data transferred by TFTP is not encrypted, so it is vulnerable to interception and modification. So the same thing goes for FTP. FTP is also not encrypted, but FTP can be, the regular FTP can be configured to require authentication. So it could be configured to require people to log in before they can access the files. So what we have to understand here is that this is an alternate way of downloading files, and we know that there's a certain file that might be exposed on the system. So we know that the ID_RSA file might be available, and we see that TFTP might be available on the system. So we might as well try it. So let's go over to our terminal. And there is actually a TFTP client included on Kali Linux, TFTP. And when you use the client, it's not going to give you very much in the way of output. And what you really need to do is you need to know exactly what the name of the file that you want to download is. And you're using the same command that you're using for SMB and FTP. It's the get command to download a file. And we're going to download ID_RSA because we know that this is a potential file that is exposed. So we run that command. We don't get any output for the command. But when we exit, when we quit, and then we look at what's inside of our directory, we see that there is an ID_RSA file in this directory. And we have a name that could be associated with this ID_RSA key, which we saw on the web page, and that is Alexia. So this is a potential username, and because we have a SSH key file in the form of ID_RSA, we can try to log in as Alexia using Alexia's key, or what we think is probably Alexia's key. So let's do that. The first thing we need to do is we need to modify the file permissions on ID_RSA, and that's going to be using the chmod command. We're going to change the file permissions to 600, which means that people in groups or people that or other users on the system aren't going to be able to read or write or execute it. And after we run this command, it's going to be suitable for using as a login method using SSH. So let's do that, SSH, and we're going to provide the key file, ID_RSA, and Alexia is the user on this IP address. So it's going to say that, it's going to ask us if we want to continue connecting. We say yes, and then now we're logged in. So we put on our hacker voice and we say, we're in. And Alexia, we are the Alexia user. Let's clear this. And then let's see if there are any sudo permissions for Alexia. So this box also has sudo disabled. So we can't use sudo for privilege escalation. So one place we like to look for any potential suspicious files is this directory right here, the opt directory. The opt directory is where we put optional software. And inside of the opt directory, we see that there's this binary right here. It's called show me the key. And we see that it's running with the superuser ID bit. So this is a SUID binary. So we might be able to abuse this SUID binary to get privilege escalation on the system. So when we run this and it's running with root permissions, let's try running it. So it seems to be an OpenSSH private key. So just for fun, let's compare this to the private key that we already have. So on another tab, I'm going to go to the directory where we have the key. So this begins with B3BL, and over on the other tab, this other key that we got using show me the key also says B3BL. So this could be the same SSH key. So what we need to do is we need to go over to Alexia's home directory, and inside of her .ssh folder over here, we see that her ID RSA file is over here. So what we need to do is we need to rename this file to see what happens when we rename the key that is being output by the show me the key binary right here. So we're going to rename this key ID RSA. We're going to move ID RSA, and we're going to rename it to ID RSA.old. Okay, so after we do that, we're going to try rerunning this show me the key binary and see what happens. So this is in the opt directory. So I'm going to run opt/show me the key. So when we try to run this file, now it shows an error. So it says, the error message says cat home alexia.ssh idrsa, no such file or directory. So what this SUID binary over here, show me the key, was trying to do is that it's accessing the cat command on the system, and it's trying to read this file right here, idrsa. But because this file doesn't exist anymore, it's been renamed, then we get an error. But this error message tells us that the cat binary could be the way to elevate our privileges, especially if the cat binary is being referenced without a complete file, without a complete file location. So usually cat is located in user bin cat, this directory right here. If this particular binary that is being used to show the key is using this exact file path, then we wouldn't be able to abuse the cat binary. But I think that it's being referenced without the full full file path, so we might be able to abuse it and get privilege escalation by creating our own malicious cat binary. So we can go into our temporary directory, and then we can create a malicious cat binary by just echoing out /bin bash. And what this is going to do, and we're going to output this into a file called cat in the temporary directory. So once we do this, we need to make sure this is executable. So we chmod it. And if we were to take a look at the contents of this directory, it's just bin bash. So this is just pointing to the bin bash program. If we're able to successfully elevate our privileges using this malicious binary right here, well, it's not actually a binary, it's just a file. We'll be able to open up a root shell. So the way we do this is that we add this temp directory that we have the malicious cat file in. We need to add this to the path variable, which is used to look for valid programs when we're running our commands. So let me take a look at exactly what we're doing here. So first of all, we need to echo the path. So the path variable is $path. So these are the directories that the system is going to look in for commands. So this is the user local bin directory, the user bin directory, the bin directory, the user local games directory, and the user games directory. So these are the directories that that the system looks in for valid commands. So what we're going to do is we're going to add the current directory that we're in, the temp directory, to this path at the beginning, so that it tries looking in. So the system tries looking in the temp directory for valid commands first. So what we're going to do is we're going to do the export path. We're going to use the export command to add to the path, and it's going to be the temp directory, and then colon, and then the rest of the path, just like this. And then when we echo the path, we see that the temp directory has been added to the path variable, which means that the system is going to look in the temp directory first, and the temp directory has our malicious cat file over here. And we know that the show me the key binary references the cat binary. So if it's referencing the cat binary without a complete file path, then we're going to be able to hijack that binary, and we're going to trick it into running the cat file right here, which contains bin bash, which means it's going to open up a root shell for us. So let's do that. So we're going to run opt show me the key, and that's going to try to reference the cat binary. And because TMP has been added to the path and the cat file contains bin bash, it's going to this show me the key binary is going to run bin bash for us and open up a root shell. So we run this, and now we are root at Hommie. Okay, so who are we? We are root. So we need to do the redeem.
What are you?
I'm system root.
All right. So what we need to do now is we need to look for the flags. So the first flag we can usually find in the home directory. And we see that there's the Alexia user, so let's go in there. So that's user.txt. Oh, okay, so we can't use cat because there's a malicious cat. There's a malicious cat file in the temporary directory. We can delete that. So rm tmp/cat, and then we can cat user.txt. All right, and it says I'm not root. That's fine. We're going to copy it and submit it anyways. Copy it, and we're going to submit it to the web page. Over at the Hommie page, we're going to submit this flag, and it says correct flag submitted, congrats. We can go back, and then we're going to look for the root flag. So the root flag is usually located in the root directory, and we see a note.txt file. So let's read it. I don't know where I stored root.txt. So we know the file name is root.txt, all we need to do is find it. So we can find it using the find command. So it's going to be find, and then the whole file system, and then it's going to be -name, root.txt, and we're going to put all of the error messages into dev null. And we see that the root.txt file is in this directory, so we're just going to copy the file path, and then we're going to cat that out. And this is the root flag. So I'm going to copy this and submit this flag. Correct flag submitted. Congrats. All right, so we're done. All right, so the last thing we need to do is we need to click on the heart button right here to show our appreciation for the challenge makers. And then we're done. Thank you very much, everybody, for joining me on this little adventure while we solved some hackmyvm.eu boxes. So we completed the connection machine, and we also solved the Hommie machine just now on our own machines over here that we deployed via virtual machine. Okay, so the next thing we're going to do is we're going to solve some CTF lab challenges. So hackmyvm.eu has a labs section over here. I'm just going to click on that, and there are three different CTF labs over here. There's Venus, there's Hades, and there's Temperance. So the last time we were here, we solved a bunch of levels over at Chapter 1 Venus. Okay, so we can go over to this page, and it shows us the initial information for this game. And if you want to join in with us, I'm going to copy the link and provide it in chat. So this game is pretty easy to play, especially the first few levels. And the problem the problem I have with this game is that the levels are not really numbered. Rather, they're named after different women. So it's a bit difficult to keep track of the levels because they're not really numbered. What I'm going to do is I'll show you what I mean. And what we're going to do is we're going to start on level 17. We got up to level 17 before we had to stop. So let me grab my notes just real quick. Okay, so what we need to do is we need to connect to the server using SSH. So first of all, I'm going to exit out of here. What I'm going to do is I'm going to shut down my virtual machine. So this is the Hommie virtual machine. We need to shut this down. Okay, then we're going to clear, and from here we're going to log into the CTF. So the CTF game is going to be SSH, and then the last level we did was the Clara level, and the Clara level was, so this is the username Clara at venus.hackmyvm.eu, and then the port is going to be 5000. Okay. Okay, it's going to ask for a password, and I'm going to provide a password. And then I'm going to log in. So if you want to join us, I've got the credentials for this particular user right here. And you can see it in the chat if you want to join in with us and you want to start on this level. There are the credentials for logging in via SSH. So let's take a look at what's in this directory. So this is So each one of these levels is going to have a mission.txt file, and that's where we're going to see what we're supposed to do in each one of the levels. So I'm going to read this, and it says the password of the user Frida is in a password protected zip file. It says rocku.txt can help you. Okay. So what we need to do is we need to transfer this protected.zip file over to our Kali machine. And we're going to crack it using John the Ripper. So the first thing we need to do is, so if we just try to unzip this file, it's going to ask for a password. Since we don't know the password, we can't unzip the file. So we need to abort. And what we're going to do is we're going to transfer this file over to our Kali machine. So an easy way to transfer small files using commonly installed tools is to use the base64 command. So we can just cat protected.zip, and then we can pipe that into base64, and that's going to turn the output of this the contents of this file rather, and it's going to turn it into base64 encoded strings. So this is what the protected.zip file looks like in base64 format. We need to copy all this, and then we're going to create this file. We're going to create this file in on our Kali machine. So we're going to go to a tab where we have our Kali machine, and we're going to create a file called protected.zip. And we're going to paste in all the stuff over there. Oh, you know what? This isn't how we do it. Okay, I'm going to exit. I'm not going to save. This is not what we do. So we echo out all of this stuff right here, and we're going to echo it into a file called protected.b64. Oh no, we're going to echo it. Sorry. We're going to echo it. We're going to pipe that into base64 decode like this. And then we're going to put the output of that into protected.zip. Okay, that should be okay. So when we see here, we've got our protected.zip file. And when we try to unzip it, it's just like the original. So we can exit out of here, and then we're going to extract the hash for this particular. Oh, okay, yeah. So we're going to use a tool called zip2john, which is going to extract the hash from the protected.zip file. So it's going to be zip2john, and we're going to run it on protected.zip, and we're going to save the output to protected.hash. Okay, so now that we've got this hash file, we can crack the hash file by using John the Ripper. So it's going to be John, and then with John the Ripper, we have to provide a word list, and the most common password list that we like to use is located at user share word lists rocku.txt, and we're going to run this against protected.hash. So when we run this program, John the Ripper is going to try to determine what the password was by trying to crack this hash. So it comes back very quickly, and it says that the password for this particular file is password123, and we can now try to unzip the file using the password we found. So unzip protected.zip, and it's going to ask for the password. We know the password is pass123, and it extracted the protected.zip when we read that. it's going to extract the protected.txt file rather. When we read that, oh, it's inside this directory. Okay. So we're going to cat this directory, copy and paste, and we see that this is the password for the next level. Okay. So we're going to copy it. And this is the password for the Frida user, because when we cat the mission file, it says the password of the user Frida is password protected. So this is the next user. So we can switch over to the Frida user. It seems like my music has stopped. So if anybody could hear the music previously, please let us know, because I'm playing around with my audio settings, and sometimes the music gets lost. So I'm going to play this playlist over here. Oh, this is nice. Okay, so we're going to switch users to Frida. And it's going to ask for a password, and I'm going to use the password that I just got. Authentication failure. Let me try that one more time. So I'm going to copy my password slowly over here. And then I'm going to switch users to Frida again and paste in the password. Okay, so we need to go to the home directory and take a look at what's here. So this next mission over here is in this file. And it says the password of Eliza is the only string that is repeated in the unsorted in repeated.txt. So what we need to do is we need to use the unique command to get only the unique strings in the repeated.txt file. If we were to just read repeated.txt, we would see that there's just a lot of stuff over here. What we need to do is we need to find the only string that is repeated when this is unsorted in repeated.txt. So it's going to be, we're going to use the unique command with the count on repeated.txt. So that's going to tell us how many times these lines appear in the text. If we run it by itself, then most of these are only going to appear once. So what we need to do is we need to sort this list. And we sort that by piping that into the sort command, just like this. And we see that this is the only line that that is repeated in this file after we sort it. So we're going to copy this, and we're going to use this as the password for the next level. Okay, so let's see if we can remember what the name of the user was by catting out the mission.txt. So the next user is Eliza. So in this case, we need to switch users to Eliza. So it's going to be su Eliza, and it's going to ask for a password, and this is the password. Paste it in, and then we are at the next level. So we need to go to the home directory, and we see that there's a mission.txt file. Cat it out. Okay, it says the user Iris has left me her key. And we see that inside of this directory, there's also a hidden file called Iris key. So all we need to do is we need to SSH into the server using the Iris key. So I'm not sure if we can SSH inside of this server. We can actually try. let's see. The iris key. I don't think the file permissions are correct, but I could always try. So I'm going to do SSH, and I'm going to try to SSH as iris, and it's going to be at localhost, which is this server, and we're going to provide a key, which is .iris_key. And let's see if this works. We're going to say yes, and now we are iris. All right, so we solved that level by logging in with the key. We're going to go into the home directory, and we're going to see that we have Iris's actual password here, so we're going to cat that out, and we're going to note this down just in case we need to continue the game as Iris. Copy that and put it in our notes. Okay, so we're going to take a look at the mission for this level. So it says the user Eloise has saved her password in a particular way. So we say that inside of this directory is a file called Eloise. So we need to take a look at what they mean by a particular way. So we're going to cat out that file, Eloise. And we see a lot of output over here. So we're not too sure what this could potentially be. So what we can do is we can copy all this and go all the way down. Okay, we make sure we get every little bit. Okay, I need to do this again. Okay, go all the way up. Whoops. Oops. That was not fun. Okay, copy everything and then let go. We're going to copy this to our clipboard, and then we're going to ask our know-it-all friend ChatGPT what this potentially is. So my suspicion is that this is base64 encoded text because of the equal sign at the bottom here, and the fact that the character set is it matches base64. It's all lowercase and uppercase letters and numbers with a couple of special characters here. We're going to ask ChatGPT, what is this? Is it encoded or encrypted? With what method? And then we include all of the stuff that we got and submit it. Okay, so over here in the answer, it says the text you provided appears to be base64 encoded. Here is the decoded form of the beginning part of the provided string. So it says over here, JFIF. So that suggests that the data is likely an image file such as JFIF that is commonly used format for storing JPEG files. So to decode the entire base64 string and verify its content, I can perform the decoding process. Let's do that for you. Okay, so what we can do, since we know that this is base64 encoded information, is we can echo this out on our Kali system, and we can output it. We can output it into a JPEG file. So what we do is back on our terminal, in our Kali terminal, we can echo, and then we can paste in that big thing. Okay, maybe we can't paste in that big thing. Hold on, maybe it's just lagging right now because that was a lot of stuff that we sent to it. Because my terminal is unresponsive. Okay, so we managed to paste in that big thing, and what we're going to do is Okay, so my terminal seems to be stuck. Okay, so I'm going to put this in a file. I'm going to put it, I'm going to nano B64 I'm just going to call it B64. And then I'm going to, inside of this file, I'm going to paste in this base64. I'm going to exit and save. And then I'm going to base64 decode the file, which is called B64. And I'm going to decode it. And I'm going to output it into, I think this is Eloise.jpg. So after we do that, we should be able to open. So if we do file on Eloise.jpg, it says that it's a JPEG image data file, which means that we can read it using the built-in Kali image viewer. So we can do that. We can run this file using its intended app by using the xdg open file, and then we provide the name of the file, which is Eloise.jpg. And this is the password for the next level. So let me copy this. So I'm going to copy this down, and then we're going to move on to the next level as the Eloise user. Okay. So back at the terminal, we are the Iris user, but we're going to switch users to Eloise. We're going to paste in her password. And we're going to go to her own home directory. Okay, so we're going to cat out this mission. And it says the user Lucia has been creative in saving her password. All right, so we see here that there is another file in here called hi. So let's take a look at what this is. So this is ASCII text. Let's read it. And it seems that, so this looks like a hex dump. So hex dumps are created by using certain programs, and that what they're going to do is they're going to change the contents of a file into its ASCII hexadecimal equivalents, or its from whatever bytes they have into their hexadecimal equivalents. So what we can do is we can use the XDD program to get the original ASCII contents. We could also try to take these hexadecimal numbers, and we could feed them into like an app to try to see what they correspond to in hexadecimal. But this way of doing it that I'm going to illustrate here is a bit faster. So we're just going to cat the file out, and then we're going to pipe it into the XXD program with the -R flag for reverse and the -P flag for printable. And this is the result, and this is the password for the next level. So this says that the user Lucia has been creative, so this is the password for the Lucia user. So I'm going to save this out to the Lucia user's password, and I'm going to save it. All right, everybody. So I'm getting a bit tired. It's been a long day and a long week, but thank you very much for accompanying me on this fun voyage into hackmyvm.eu. This website has a lot of fun challenges to complete, and it's over at hackmyvm.eu, the website, which is over here. I'll provide the link in chat. And if you feel like solving the challenges over here, please give me you can give me a message on Reddit over here. We have our Reddit page at reddit.com/HackerFrogs. And we're always looking for fun community interactions. Every week we post up our streaming schedule over here, and we are live right now, so I decided to put this up so people can come in and see us live. But to everybody who joined us today, thank you very much, and we'll see you next time. The next time we're going to be live is on Monday, and we're probably going to be doing our regular HackerFrogs web app hacking course, and we're going to be diving into SQL injection. So please look forward to that. What else are we going to do after that? I'm not too sure. I'll probably figure that out over the weekend. But thank you very much, and let's go out with All the Things by Dual Core.
This one's dedicated to all the hackers. Yo.
All right, everybody, have a great weekend, and we will see you next time.